Hey everyone, welcome back to my channel EduVibe. In today's lesson, we are moving to the last thing of the unit C, which is the extra practice questions we are doing. And today we're completing that unit, and with that, we left with only one unit. So let's start with the extra practice question with the first topic, where we do the de-association of the iconic compounds. So we have a magnesium bromide. They mentioned that they are placed in water, so we have to do de-association of this. So Mg is 2 plus, I think, yeah. Mg 2 plus, this is Br minus. You will get MgBr2. Then this is a solid, and you will get in water. So you will get Mg2 plus aqueous plus Br minus aqueous. You have to balance this, so put 2 over there. So this is for the magnesium bromide. Next one is the sodium phosphate. What's the formula for sodium phosphate? You have PO4 3 minus and Na plus. So it's Na3 PO4, which is again solid, and they place it in the water. And what's next? We deassociate this. So Na plus aqueous, which is 3 plus PO4 3 minus aqueous. So this is the sodium phosphate deassociation reaction. Next, we have a potassium nitrate. Nitrate is a polyatomic particle again. So it's NO3 negative and K positive. So we get KNO3, again solid. And you get into the water of this. You get K plus aqueous plus NO3 negative. So easy. Yeah, so but just doing the deassociation thing when they place in the water. So you kept doing these examples and by your own, and you will like good in that after that. Next question we have. The plastic copper bottle for a chemical analysis contains 0.11 mole of calcium chloride in 60 ml of solution. Calculate the molar concentration of the calcium chloride. You have N given and you have volume given. You want to find the C in this. So this is a simple kind of question. You just have to find the C in this. So you know C is equal to N upon V. N is 0.11 moles. You have to convert the 60 ml into the liters, so you get 0.06 liters. When you calculate this, you get about 1.83 moles per liter, which is basically the 1.8. You want two sentence. So easy question, but you get some complex questions too, which we already discussed when we're doing that topic, which is all the molar concentration. So we check this video and practice the more complex questions in that. So yeah. So next question we have. So question says a bottle of 5.0 moles per liter hydrochloric acid is opened in a laboratory and 50 ml of is poured into the beaker. So what chemical amount of acid is in the beaker? So they give you the C now and they again give you the V, but you have to find the N. So it's the same thing. C is equal to N upon V. So C is 5.0 moles per liters and you have to find V is 50 liter, which is 0.05 liters. To find the N, so multiply the whole both things. So liters cancel and you get the N of about 0.25 moles. Two sentences. That's your answer. They will do a V also, but after they mentioned you have to find the V in milliliters. So at the end you have to convert this. First you have to go with the liters, and at the end you have to convert into milliliters. So that's the concentration part, and let's do the next question. The brass is a copper zinc alloy. If the concentration of the zinc is relatively low, the brass has the golden color and is often used for the inexpensive jewelry. If a 35.0 gram pendant contains 1.7 gram of zinc, what is the percentage mass by mass of zinc in the brass? So you have to find the percentage mass by mass. So we have a percentage mass by mass. Here you have a two masses which have in the same unit. So 1.7 grams, you have to divide this by the 35.0 grams because this is a solute, and pendant is like a large thing which is in the solution type thing. And multiply by 100, you will get 4.85% volume by volume, which is basically the 4.9% mass by mass. This is the percent concentration we did. We do the mass by mass, volume by volume, mass by volume. So you have to take care of things like which thing is like mentioned and what you have to find. So that's very important. If the units are different, so you have to convert one of the unit of the mass. Let's do the next one. The question says a student's silver ring has the mass of 12.0 grams. The percent mass by mass concentration of the silver in the ring is 92.5%. Determine the mass of the silver in the ring. So now you have to find the mass of the silver. They've given you the mass by mass concentration. So now mass by mass is equal to the mass of the solute, which you have to find silver, and you have a mass of the solution over there. Then multiply by 100. So the mass by mass is given, which is 92.5%. You have to divide this by 100. Then, and the mass of solute you have to find, the mass of solution is given is 12.0 grams multiplied by 100. Or you can like you put like 100 over there, so ignore that sign. And now 92.5 divided by 100 multiplied by 12.0 grams is equal to the mass of solute. When you calculate this, you get your mass of solute above 11.1 grams. Sometimes they give you like this type of thing too. Reverse thing. So that's how the mass by mass volume again works. Next question we have. The Olympic bound athlete tested positive for the analogical testosterone and alone. The athlete's urine test results showed 0.20 mg of the mandolone in 10.0 ml urine sample. Convert the test result concentration to the parts per million. So you have to convert the something in the parts per million, and they give you the mass in mg and the volume. So how can you deal with those? So you have to find the PNP thing, and you have a mass and you have a volume, which means you have a mass of something with the mass of the solution. So you have in mg or milliliters, but you have to be in mg and liters for this type of question. So you have to convert this 10.0 into the liters, which is 0.01 liters. Then 0.20 mg divided by 0.10 liters. Then you have to go with mg with liters and mg with kgs like this. That's why I convert this. Then in ppm you get 20 ppm. Easy question. But you just know this thing. If you take that straight, you will get the wrong answer. Mg with liters, mg with kgs. Both are different. So that's how you can deal with those. Next question we have. A 250 ml solution prepared by dissolving 2.01 gram of iron chloride in water. What is the molar concentration of each ion in the solution? So you have to find the molar concentration of each one. So this is the reaction thing. So you have iron chloride, which is like FeCl3. So I have to make the reaction first. FeCl3, which is solid, goes with water in liquid. You will get Fe3 plus aqueous plus 3Cl minus aqueous. So you have a mass of the iron chloride. So if you have a mass, so you have to find the molar concentration of this, which is about 162.2 grams per mole. And you can find the N from here. You get the N of 0.0123921 moles. Done. And you have a volume given, which is 0.25 liters. And you can find the C from here. When you find the C, you will get the FeCl3C of 0.04958 moles per liter. Then you have to find the each ion. So you have to find the concentration for this and this. So the concentration for Fe3 plus is equal to 0.049568 moles per liter. So we get mole multiply by 1 by 1. So concentration of this is 0.0496. It stays the same. Moles per liter. Done. For concentration of Cl negative, so 0.04956 moles multiplied by 3 divided by 1. So for this, you will get 0.149. So you know how to deal with those. Required and given, coefficient of required and given. So that's all. We already discussed lesson 2, concentration of ions in the solution. So you can go and watch this too. So this is how that question works for this. So next question we have over there. The technician prepares 500.0 ml of 0.0750 moles per liter solution of potassium permanganate as a part of a quality control analysis in the manufacture of the hydrogen peroxide. Calculate the mass of the potassium permanganate required to prepare the solution. So in this, you have to calculate the mass, but you have some things to given. You have to find the mass for potassium permanganate. So you want the molar mass for the potassium permanganate too. What is the mass for that? So potassium permanganate is basically KMnO4. So the molar mass is become like 39.10. Then you plus with that things and you get about 158.04 grams per mole. Then and you find the mass. So you have a volume given 0.5 liters. So you know C is equal to N upon V. So N is equal to C times V. So C is given and also V is given. So what's the N? 0.0375 moles. So you know N is equal to mass upon molar mass. So mass is equal to moles, chemical amount of moles, and the molar mass. So you put the things. So 0.0375 moles multiplied by 158.04 grams per mole. Moles cancel. You will get a mass of about 5.93 grams. And this is from the Papageau standard solution. When we do the first step, you do the mass calculation in that. Done. In the second part, you have to do the dilution in this, where we do one formula, and the formula is VICI is equal to VFCF. That formula is used in that question. Radiator antifreezer is diluted with an appropriate quantity of water to prevent the freeze of mixture in the radiator. 4.00 liter container of 94% volume by volume and antifreezer is diluted to the 9.0 liter. So calculate the final solution of this. So in this, you find the final concentration, which is the CF. You have VI is 4.00 liters. You have CI, which is 94% volume by volume. You have VF2, which is 9.00 liters. You have to find CF. Your CF will also be calculated in percent volume by volume. Done. So VI, you have to isolate the CF in from there. So CF is equal to VI CI upon VF. So VI is 4.00 liters, CI is 94% volume by volume. Divide this by the 9.00 liters. Liters will cancel. You will get about 41.7% volume by volume, which is basically the 42% volume by volume. Done. That's your answer. So if this is in this, so it cuts out liters, it cuts out, you get the 42% in volume by volume thing. Okay, the next question we have from the pH thing. So Na3PO4 forms a solution with the pH of 8. This is from the modified NS theory. So Na3PO4 solid forms a pH, so it's basic. Then firstly you have to go with the water, which is deassociation, and you will get a 3Na plus aqueous plus PO4 3 minus aqueous. Then after that you have to go with you have to eliminate the 3 minus and 3 minuses and get the 3H. So I have to do 3 reactions, and there's not very much space I have. Plus water, you will get HPO4 2 negative aqueous plus OH negative aqueous. Again go with that 2 negative aqueous plus water, you will get H2PO4 minus aqueous plus OH negative aqueous. The last reaction, H2PO4 negative aqueous plus water liquid, you will get a H3PO4 aqueous plus OH negative aqueous. The 3 dash after that. Next we have a KOH solid, yields the solution with a pH of 12. So this is a simple thing. So KOH is in solid, you just do the association of this and you will get a OH negative aqueous plus K plus aqueous. So this is a simple thing. This is the other thing, the last thing we did. So KOH goes with the association, OH negative and A plus. Simple. Next question, next part we have this CaOH2 aqueous. So CaOH2 again, same as KOH. This is in aqueous. Go with water in liquid, you will get Ca2 plus aqueous plus 2OH negative aqueous. Simple equation. For this CRO solid, you will do the two equations of this. How can you do? Firstly, you go with the water and you will become the CrOH2, simple equation for this. Now you do the deassociation of this in presence of water. You will get Sr2 plus aqueous plus 2OH negative aqueous. That's the how the modifiers theory works. This is not an example for the acid, but I do only for the bases. Yeah. So you can do the practice for this. You will get a good in that. Next we have for the pH and pOH thing. The first one is the grape juice. We have the concentration of anhydronium with that. So we have to find the pH in this. Done. So with pH, minus log of this, you have to memorize those formulas, which we did. You can watch the full lesson. Done. So pH is equal to 2.68 for this. If this is a 2 sentence, right? 6 and 8 because this has a 2 sentence. Next we have ammonia cleaner which pH of 11.3. So we have to find the hydronium ion concentration in this. So hydronium ion concentration is equal to 10 raised to the minus 11.3. Then when we calculate that 5 into 10 raised to the minus 12 moles per liter. Again, it has a 1. 3 only has the 1 seconds. So we have only 1 seconds. So that's your answer for this. That's how the pH and pH is working. The last questions we have from the monoperiodic and the non-polyperiodic thing. For HBr, we have to say that it's the monoperiodic or the non-periodic. So we have a HBr aqueous. We have to do the with water, and we will get hydronium ion plus Bn negative. So there's only one hydronium ion, so which means this is the monoperiodic. So that's all for this unit, and we completed a unit now. So this unit C is also completed. Now we left only unit D, which we start as soon as possible now, and then we commit with the grade 11 chemistry. So that's all for this lesson. My name is EduVibe, learn smart not harder. Please like and subscribe to my channel. If you have any questions, let me know in the comment section. See you in the next lesson. Till stay with EduVibe.